is homework number 11. And I'm going to do number 25. Of course, your numbers might be a bit different, but the idea is still the same. So if you got x squared minus 4x plus 2, I want to set it equal to 0. Well, it's set equal to 0, and I want to solve by completing the square. So solve by completing the square. Okay, so what does a completing the square entail? It entails creating a perfect square trinomial. So that's the idea behind completing the square. I complete the square means I take the a part of the trinomial, which is just two terms here. And what I do is I'm going to add something to it so that I create a perfect square trinomial, which I can factor and finally solve for x. So the first order of business is to get rid of that -2. To get rid of that 2, that constant. So I subtract by 2. And then I'm left with this here. I'm left with x squared minus 4x. This equals -2. So that's the first step. Then I realize, wait a minute, I have this -4, this 4. And yeah, it is a bit tough, Samir, but I don't think we're going to go over all the last chapters of the textbook. So don't worry about that. But anyways, so 4, what we're going to do with 4 is we're going to take 4, we're going to divide it by 2, and we're going to square it. That's the completing the square part. That's it. I take the number in the middle, in front of x. I divide it by 2 and I square it. The moment I do that, what do I get? I get plus 4, right? 4 divided by 2. 4 divided by 2 is 2. And when I square it, I get 4. So what I really just did is I added by 4. So I'm going to write this again. X squared minus 4x. I added by 4 because 4 comes from taking 4 divided by 2 and squaring it. Now, what happens is whatever I do on the left side of the equation, I must also repeat it on the right side of the equation to keep it as an equation. So I must add by 4. Okay, and then on the right side of the equation, I get a plus 2, right? Because -2 plus 4 is 2. And then I have x squared minus 4x plus 4 equals 2. But the whole point of adding this 4 here is I created what's called a perfect square trinomial. That's the whole point. Once I have the perfect square trinomial, I can factor this as x minus 2 squared. Because if I factor it, that's what I get as my factorization. This equals 2. I want to get x by itself. So I must square root both sides. When I do so, I get x minus 2 is equal to plus or minus rad 2. And then I have to add the 2 on both sides. And I'm left with x is equal to 2 plus or minus rad 2. And this is my final answer. These are my solutions. I got the 2 plus rad 2 and 2 minus rad 2. I hope that clarifies a bit the completing the square portion of solving a quadratic equation by the completing the square method. So any questions about those steps? And I just want to make mention, so if you look at the one right after that, right, number 26. Now, what you have to do here, number 26, on mine is like this. It's 2u squared minus equals 4u plus 1. That's the way that mine looks. Yours could look a little different. So in this case, right, I always want to have the terms with the variables on the same side of the equation and the constant on the right side. So I must subtract the 4u on both sides. And so I get 2u squared minus 4u equals 1, okay? Now, the difference in this kind of scenario is, if you notice, there's a 2 in front of the u squared, whereas in the x squared here, there's only a 1. When you just have a 1 and or you don't see any number in front of the x squared, you move on and do these steps accordingly, right? But whenever you have a number that's not a 1, that it could be a 2, a 3, a 4, a 10, 1,000. If you have a number in front of the x squared term, or in this case, the u squared term, and it's not a 1, then what you have to do before you do anything is divide everything by that number. Divide everything by that number in front of the u squared so that you can do the completing the square. You can't complete the square if you have a 2 or a 3 or a number in front of the x squared term. You can't. So you have to first divide it out. And then you get this, you see? Then you get this. And then you take 2 divided by 2, square it. 2 divided by 2 is 1. You square it. You're really just adding a 1 on both sides of the equation. And now this is a perfect square trinomial that factors into u minus 1 squared. 1/2 plus 1 is really 3/2. Take the square root. Take the square root. And you get that u minus 1 is equal to plus or minus the square root of 3 over 2. And then you get that u is equal to 1 plus or minus the square root of 3/2. And of course, you can make this a little bit nicer. Let me do that for you. So 1 plus or minus rad 3 over 2. I can write this as 1 plus or minus rad 3 over rad 2. I want to rationalize it, rad 2 over rad 2. And I'm left with 1 plus or minus rad 6 over 2. Then I can put this as 2 over 2 plus or minus rad 6 over 2, and I can rewrite this as 2 plus or minus rad 6 all over 2, and that equals u. So both of these are correct. It's just that one of them is as a single fraction. So this is a single fraction version of it. So a single fraction. But like I said, both of these are the same. Okay, so when you have a scenario that looks like this, you know also how to take care of it, and that's by dividing out that first constant here. Just divide that out through every term, throughout every term, divide it out, and then you complete the square, and you go on. Okay. Okay. Any questions? Yeah, no problem. Yeah, guys, just let me know whenever you have issues. You know, it's not just me talking about the next thing. It's also I want to make sure you guys are prepared. You guys are understanding what's going on. You know, and the best way, hopefully, you guys have realized the best way to learn anything, particularly in mathematics, you have to do it on yourself. You have to do it by yourself. You have to do it on your own. You have to be able to know how to do something, and to know how to do something, you have to have seen it, experienced it, experienced the difficulty, experienced how it feels to not be able to do it, and then you're able to figure out how to do it. You have to go through that on your own. It's not just by looking at me, because I can do this all day, every day, and you can just look at me, just do the problems by myself, but that does not translate to understanding, to your own understanding. So mathematics is not a spectator sport. You have to do it yourself at one point in time. Okay. Okay. So good. Completing the square. Again, we're gonna go back to this. This is gonna be an essential algebraic skill. So we're gonna do more of this anyways. Okay. So we have so we've talked about parabolas, right? But one thing I want to talk about are conic sections. I don't know if you've heard of this before, but essentially it's just a fancy way of saying shapes formed from cross sections of cones. So the idea is this, and this is when you have to kind of use your imagination a bit. Um, make believe, there's a lot of make believes here. Make believe you have a double inverted cone. Okay. And make believe this cone is made out of this double cone here is made out of a very thin material. And you also, there's a lot of make believe here, a lot of imagination. Make believe this cone goes up forever to infinity and goes forever downward. So this just keeps on going and going and going further downward, and this keeps on going further upward. So make believe, if you can, in your head that such a thing actually exists and you can see it. And the way I like to think about this is make believe as well that you have a very sharp sword, a katana blade or something like that, right? And depending upon how you cut this cone, you have a certain cross section, you have a certain outline of a shape that's formed. So, for example, if I were to cut horizontally parallel to the opening, right? If I were to cut this, the shape that would be formed by this outline would be a circle. So if I were to cut this, I would have a circular outline, right? So there's four of them that I have. So four conic sections. There's four. So one of them is a circle. And we're going to talk about circles. Now, what's the other one? The other one is, what if you cut it horizontally, but you don't cut it exactly parallel to the opening? What if you cut it slightly, like a slight angle, in a certain angle? So in that case, you wouldn't have a circle anymore, but you would have a somewhat of a circle, but it's a bit elongated somewhere, right? It's going to be, maybe I should do this again, something like this. So in this case, it's not a circle, it's called an ellipse. People use the word oval a lot, but the mathematical term is an ellipse. So an ellipse is like an elongated circle. So I'm going to draw this. So this is what we know as a circle, and then an ellipse would be just a bit, like elongated. So that's an ellipse. Now, what else can I do? There's two more shapes that I can create. Now, what if I also cut I also cut diagonally, but I cut it instead of parallel to this, I cut it parallel to one of the sides. When I do that, I don't know if you're able to see this, but I have what's called a parabola. So I can create a parabolic shape if I were to cut it in this fashion. So I'd have a parabola. And then lastly is if I cut it vertically downward. If I were to cut this vertically downward, let's see, do I have another? If I cut it vertically downward, I would have something like this. And this is a more complicated shape. This is called a hyperbola. So what it looks like is that it looks like almost like a parabola, but there's two of them. So these are the four conic sections. And the ones that we are particularly interested in is the parabola, which we've talked a lot about last time, quadratic, right? We learned how to find the axis of symmetry. We learned how to find the vertex, the x-intercepts. So we learned how to graph one. And now we're going to be talking about a circle. So we'll be talking about what a circle is and how to graph one, how to interpret the information that we're given. Okay. So what is a circle? I like asking this question because people think they know until they're asked this question. And then when they try to answer it, their answers aren't usually sufficient. The first thing people ask, right, when I ask, oh, what's a circle? Well, let me ask you guys, what is a circle? Anybody have a good definition? So one of the first things people say is, oh, they see two things a lot. They say either it's round or they say it has 360 degrees. And yeah, David, that's right. People say it has no angles or they say it have no corners, right? But if you just base off of that answer, for example, an ellipse also has no round is round and also goes around 360 and also has no shape, a shape with no angles, quote unquote, no vertices. So an ellipse also fits that description. So then you're like, no, no, but that's not true, right? Because we're not talking about an ellipse, we're talking about a circle. So what makes a circle special? And so then when you start to think about that, you start to think about how can I make my definition more accurate, more refined, and more complete so that I can always say this is what a circle is. So a circle, same radius. So I think so Mang, that's right. But then the question is, what's a radius? So you have to define a circle with more elementary um, phrases because a radius is a specific description of a circle. And that's right, though. You're right. A circle is a collection of points. And I would say it's an infinite number of points. So let me just put this as a question, parentheses. A circle is a collection of points that are all equidistant. They're of equal distance to a particular point in space. This is the very specific way. So this particular point, right, we're going to give it a name. The particular point that every other point is equidistant to is called the center. So if you take like a speck of dust and make that the center, right? And then every point is of the same distance to that point, you create a circle. That's not a circle, that's an ellipse. You create a circle. Boom. So the idea is that every point, I don't care where it is, right? If I take this point here, if I take that point here, if I take that point here, if I were to draw a line that connects the distance to that point, right? Make this point a little bigger. So this here is my center. And this is just a random point, right? A random point on circle. The distance from that random point of the circle to the center, this is known as my radius. This is my radius. This is my radius, right? They're all the same. That's the idea, guys. The idea is that every one of these line segments, it doesn't matter where you go, right? Doesn't matter where you go on the circle. they're all the same length away from the center. And that's what a circle really is. Okay, so now once you have that understanding of a circle, the interesting thing is, how do we translate that to mathematical formula representation, algebraic representation? How do we do such a thing? So what we find important, obviously, is the center. So what we're going to give the center are the coordinates h, comma, k. H represents the x coordinate of my center, and k represents the y coordinate of my center. And then I'm going to choose another point somewhere. I'm going to call it x, comma, y, just to represent a random point on the circle. And then the radius, I'm going to give it r, right? R is going to represent the radius. Now, do you guys remember the distance formula? So let me write that down. So recall the distance formula. We did this a long time ago, near the beginning of the semester. Does anybody remember? The distance formula was given by this long square root, right? The distance between 2 points is x1 minus x2 squared plus y1 minus y2 squared. That was the distance formula. If you have the 2 points in space in the xy plane or the Cartesian plane, and you want to find the distance between those 2 points, you apply this formula. And really, this formula is really just the Pythagorean theorem hidden. So it's really just applying the Pythagorean theorem. Now, what's the distance? So now we're going to apply the distance formula. Apply distance formula for the point h comma k and x for the points h comma k and x comma y. Now, what does h comma k represent again? The center. What does x and y represent? It just represents a random point on the circle. Random point on circle. Now, what do I know about every point on the circle and the distance from that point to the center? It's always the same, the radius. And the radius here is r. So the distance between the point xy and the point h comma k, I already know the distance. It's r. So under this formula, this is what I get. I get r is equal to the square root. And what I'm going to do is I'm going to take the difference between the x values. So what's the difference between x and h? X minus h. Square that. And then I find the difference between the y values, which is going to be what? Y minus k. And then if I square both sides, I get rid of that square root, don't I? And so finally, what do I get? I get x minus h plus y minus k squared equals r squared. And guess what? Guess what? This right here is the equation of a circle. This is the equation of a circle with center equal to h comma k and radius equal to r. That's it, guys. This is the equation of a circle. X minus h squared plus y minus k parentheses squared equals r squared. So first I'm going to show you the simplest kind of circle, most basic kind of circle that we have. It's called the unit circle. And the word unit obviously implies one, unit, one. So this occurs when the center is at the origin, 0, 0, and when the radius equals 1. So again, my h is equal to 0, and my k is equal to 0. When I plug in the equation, what do I get? I get x minus 0 squared plus y minus 0 squared equals 1 squared. But what's x minus 0? X minus nothing is just itself, right? So I get x squared. And what is y minus 0? Well, y minus 0 is also just y squared equals 1. And so this here, this equation represents the equation of the unit circle. This is the equation of the unit circle. Okay, that's my equation. So we're going to be interested now in finding the equation based upon information that they give. So finding equation of a circle. So example, what if my center is -1, 2, and my radius is 4? What's the equation of the circle? Remember what the equation of the circle is. It's x minus h squared plus y minus k squared equals r squared. What is h? It's -1. What is k? It's 2. So I get x minus -1 squared plus y minus 2 squared equals 4 squared. But what's x minus 1? X minus 1 inside the parentheses is x plus 1. So my answer is x plus 1 squared plus y minus 2 squared equals 16. And I'm done. I don't need to do anything else. I'm not solving for x. I'm not solving for y. I want to know the equation of my circle. And I need to find the equation of the circle. I have to use the center and the radius. Once I have the center and the radius, I have a circle. And this is the equation of a circle whose center is -1, 2, and whose radius is 16. Okay. That's the idea. That's the idea, guys, for now. So let's do one more of these and then you get the hang of it. So what if the center is 2, -3, and whose radius is 4? You know what? Let's make it 5. So what's the equation of the circle? Well, what is h? It's 2. What is k? It's -3. So plug it in, right? X minus 2 parentheses squared plus y minus -3 squared equals 5 squared. X minus 2 squared, I just leave it as x minus 2 squared. Y minus -3 becomes y plus 3 squared, and 5 squared is 25. And that would be it. Okay, does everybody see that? Once I have the center and the radius, all I have to do is plug it in the equation of my circle, which I know the equation of the circle is given by this equation. As long as I plug in the h and the k and the r, I get the equation. Now, I want to give like a brief sketch to this. Let me just change this really quick, dotted paper. So I want to give a brief sketch. So sketch, we should be able to sketch the graph of x plus 2, pardon me, I think it's minus, minus 2 squared plus y plus 3 squared equals 25. From this here, I already know, right, that the center is 2 comma negative 3, and the radius is 5. Okay, and then when I want to graph this, if I want to graph this, I have to plot the center first. Where's my center? 1, 2, 1, 2, negative 3. So this is my center right here. Boom. That's my center. And then what do I know? I'm 5 units away from the outer part of my circle. So I'm going to do this. I'm going to move directly above. 1, 2, 3, 4, 5. That's going to be my 1 point. 1, 2, 3, 4, 5. Second point. 1, 2, 3, 4, 5. Third point, and then 1, 2, 3, 4, 5. So I know that my circle must touch each of these points. Let me see if I can do this. And I get a circle that looks similar to this. And this would be the sketch. This is my x-axis, this is my y-axis. This is my center. 2 comma negative 3. And then I can also plot my radius. My radius is 5. So there we go. This would be a sketch of the circle x minus 2 squared plus parentheses y plus 3 squared equals 25. Okay? Okay. Okay, good. Now that I have this idea behind circles, equations of circles, the center, the radius, now we'll be dealing with problems where I'm going to be given an equation of the circle, but I won't have it in standard form. So let me just say one thing about this equation here. This is not just any equation of a circle. This is the standard equation, standard. So I'm going to sometimes be given equations of circles that are not standard. So this is writing equations of circles in standard form. So an example of that. What if I have something like this? X squared plus y squared plus 3x minus 2y minus 1 equals 0. This is an equation of a circle, guys. The problem is I don't have it in the standard form. Remember, standard form. What was standard form? X minus h squared plus y minus k squared equals r squared. So what do we do? Well, good thing we learned about completing the square. We got to complete the square. And what we're going to do is we're going to complete the square twice. So to write equation of circle in standard form, we may need to complete the square twice. So what we're going to do is we're going to group. So in order to do that, we have to group x terms together, y terms together, and move constant to other side of equation. So let's group all the x terms together. So x squared plus 3x, that's one term, right? I'm gonna put these in blue. I'm gonna leave a little space. Then I'm gonna add by y squared minus 2y, that's another term, y terms. And then that minus 1, I'm gonna add it by 1 on both sides, and I get 1. So see what I did here? I did step 1, which was to move all the x terms together, move all the y terms together, and move the constant term on the other side of the equation. And then the next thing I do is complete the square twice. Complete the square twice. So to complete the square for 3, what must I do here? What must I do to the 3 to complete the square? Remember, I take 3 divided by 2 square. Because I do that, I must also do it on the other side. 3 over 2 squared. Okay. And then I need to complete the square for the next term, which is y minus 2, y squared minus 2y. So I got to get the 2 divided by 2, square it. But I did that here. I must also do that here as well. Now, what do I get? I get x plus 3x, x squared plus 3x plus 9/4 plus y squared minus 2y plus 1 equals 1 plus 9/4 plus 1. And now what? Now this here, they're both perfect square trinomials. The x squared plus 3x plus 9/4, this becomes x plus 3/2 squared. Y squared minus 2y plus 1 becomes y minus 1 squared. And then what's 1 plus 9/4 plus 1? Well, 1 plus 1 is 2. 2 plus 9/4, I can write this as 8 over 4 plus 9 over 4, which is 17 over 4. So the equation that I got, so my equation in standard form, standard equation, I should say, equation in standard form the equation of the circle in standard form is x plus 3 over 2 squared plus y minus 1 squared equals 17 over 4. So this is my equation. And then based upon this information, this equation in standard form, I can figure out the center. I can figure out the radius as well. So what's the center? Remember, my formula is x minus h squared. I got x plus 3/2. So the idea is this, guys. To find the center, all you have to do is look at the numbers inside the parentheses and just switch the sign. That's it. So if I got a plus 3/2, my center is negative 3/2. If I have a y minus 1 here, my y coordinate is positive 1. So my center is negative 3/2, comma 1. And how do you get the radius? Well, remember what this represents here? 17 over 4 represents r squared. So I want to find r, not r squared, but r. What do? Square root. And then I get r is equal to the square root of 17 over the square root of 4, which is 2. So my radius is some strange number, rad 17 over 2. The reason why there's no plus or minus is because we're dealing with radius, and radius is a distance, and distance is always positive. We could never talk about a negative radius. We don't know what that is, but we know about positive radii. So this is the information that I'm able to get now from the standard form. So if I have something in standard form, I can figure out the center and then figure out the radius. You figure out the center by getting the x values, the values that you have next to the x and the value you have next to the y. Just negate, flip the sign, and that will be your corresponding center coordinates for the center. And then the number that's outside as a constant, to get the radius, just take the square root and you'll get the radius. So that's the idea, guys, behind finding the equation of a circle and putting it into standard form. And once you have it in standard form, being able to interpret what that is. So let's do one more of these and then think that will be it. Yeah, that should be it. So that next one here, x squared plus y squared plus 4x, pardon me, minus 4x plus 8y plus 15 equals 0. Okay, so I want to convert this. So convert to standard form. Of course, we're talking about circles. What do I need to do? I need to pair up all the x squared the x terms. So x squared plus, pardon me, minus 4x, leave a space, plus y squared plus 8y, leave a space, equals negative 15. I move the 15 from the left to the right. Then I have the x terms and the y terms, and I want to complete the square 2 times. To complete the square for 4, I do 4 divided by 2. That's 2, square that, and I get 4. So I'm really adding a 4, and I'm adding a 4 on both sides. For the y squared plus 8y, I take the 8 divided by 2, which is a 4, and I square it, and I get 16. So I'm adding by 16, both the left side and the right side. Now that I have x squared minus 4x plus 4, I can factor that as x minus 2, parentheses squared plus, and then the y squared plus 8y plus 16 becomes y plus 4 squared. Negative 15 plus 4 plus 16, that's equal to positive 5. So guess what? I just completed writing the equation of the circle that I originally had into standard form. So I wrote it in standard form. Now that I have it in standard form, I can figure out the center. Remember, the center is just the opposite sign of each of those numbers that are next to the x and the y's, respectively. So negative 2 inside the x becomes positive 2 for the x coordinate, and the positive 4 becomes a minus 4. So my center is 2 comma negative 4. What's my radius? My radius, remember that number on the outside of, on the right side of the equation? It equals what? It equals r squared. That equals r squared. So what does r equal? Square root of 5. So based upon the standard form, I'm able to figure out the center and the radius of my circle. So see, in this problem, we also needed, for circles, we also needed to understand how to complete the square. So completing the square is a very important algebraic technique to master. Okay, guys, so that was it.